So in 8.4, we're going to talk about right triangle trigonometry. And a lot of this you may have heard of before. So we have the SOHCAHTOA as our little kind of acronym to help us remember these basic trig ratios. So what trig does is it helps us find sides and angles. So sine, cosine, and tangent are the three ratios that we're going to be looking at in this unit. So it has to be a right triangle, and in a right triangle with acute angle A, we would then set up our ratios for sine of A. So SOHCAHTOA. So this is the opposite side over the hypotenuse side. So going from A, I like to circle the angle I'm going to go from. For sine, opposite is going to be little a. And then the hypotenuse is a little c. So that would be the ratio that we would use. So from A, cosine, ca, the adjacent means next to, and it's not the hypotenuse, it's the other leg. It's a leg, not a hypotenuse. Adjacent can't be the hypotenuse because we already have the hypotenuse. So the adjacent is going to be the B. The hypotenuse is going to be the C. And then tangent is TOA, and from angle A, that's what it's telling us here with this A, we want to go opposite, so little a, over adjacent. So B, again, it is not C because C is the hypotenuse. So now we can go ahead and do it from a different angle as well. This one is angle B, sine from B. So opposite over hypotenuse, B over C. Cosine ca, adjacent over hypotenuse. So next to over the hypotenuse, so A over C. And lastly, tangent, B, so TOA, opposite, so B, over adjacent, A. So in a right triangle, the sine A squared plus the cosine A squared equals 1. Let's go ahead and take a look at a couple of examples with actual numbers in them. So our first one, we're going to express sine L. So we're going to circle L because that's the angle we're going to go from as a fraction and as a decimal. So sine, so is going to be the opposite over the hypotenuse. So opposite is 12, hypotenuse is 37. So sine L, and then that's approximately, if we type that into our calculator, 0.324. All right, cosine L. So the ca, if we're looking up here to help us kind of remember that ratio. So still from L, the adjacent is going to be 35. Hypotenuse is 37. So cosine L is that fraction, which is approximately 0.946. Okay, tangent L. So TOA, O over A. So going from L, opposite is 12. A adjacent is 35. Again, not the hypotenuse. And that is approximately 0.343. So I want you to try these next three on your own, going from N, sine, cosine, tangent, and then check when you're ready. So hopefully you got these three answers correct. If not, take a look and see where you made a mistake. So as we move on to using our calculator for more things, you need to be very careful. Make sure that your calculator is in degree mode. Most TI 83s and 84s, they default to radians. So you do need to make sure that you are in degree mode. So go to the mode button or settings on your calculator and make sure that it's in degrees. This little symbol here, theta, is basically used to show angles. It's kind of an unknown symbol for angles, kind of like X. So you may see that in some of your pictures. So let's take a look at our first example here. We're going to use this special right triangle over here, 30, 60, 90, to figure out what the X is. Okay, so let's go ahead and go from our 60-degree angle here, and let's go ahead and use cosine ca adjacent x. So cosine 60, we put our degrees in here, our angle, if usually we use the letters, but if we know the degrees, we put the degrees, equals our ca adjacent over hypotenuse. Okay, so this is the same thing as 1 over 2, 1/2. So we can go ahead and say and so really when we type this just cosine 60 into our calculator, we can see the fraction here just with our representation, but typing it into our calculator we get 1/2 or 0.5 as you might see it on your calculator. So kind of practicing typing that in. So as we get to these problems here, if you don't have a picture, you definitely want to draw a picture and label it. And then we got to make our way through the know, need, and use. And that really helps us set things up. So what do we know? Well, we know the theta, the degrees, and we know the hypotenuse. What do we need? It looks like the relationship that we need from the angle here is opposite. So O, we need the opposite. So what are we going to use? What uses O and H? Sine. Sine of theta equals O over H, or opposite over hypotenuse. So that's how we're going to set this up. Sine, well, we know our degrees is 7, so sine 7 equals our opposite, which we don't know is y, and our hypotenuse is 5. So what we're going to do is cross multiply. So 5 times sine 7 equals y. And we're going to type that straight into our calculator. 5 times sine 7, making sure we're in degree mode. And then we're going to get 0.6 feet. And we're done. So let's go ahead and try another one. And then we will have you try some. So what do we know? I say circle your angle. I say label what you have, O, A. So what do we know? We know our adjacent. We need our O. So what are we going to use? What uses O and A? Tangent. Tangent of our degrees equals O over A, and we have our degrees. So tan 62 is equal to O, which is unknown, over adjacent, 11.7. So then we're going to cross multiply. 11.7 times tangent 62 equals x. And so x is going to equal 20.69. We round to the nearest hundredth there. Okay, So go ahead and try B and C if you're feeling ready. Otherwise, you can kind of follow along at least for this next one. Circle the angle, label the two pieces here, adjacent and hypotenuse, so you know you're adjacent. You need your hypotenuse, which means you're going to use ca or cosine theta equals A over H. So cosine 27 equals adjacent 5 over hx. So this time we're actually taking x times something. What you can do is just switch these. Because they are opposite each other, we can just switch them. So x is actually going to equal 5 over cosine 27, and we'll type that into our calculator. So x is going to equal 5 divided by, make sure cosine 27's in parentheses, we're in degree mode as well, so 5.61 approximately. So try that last one, pause, and then go ahead and check when you're ready. Hopefully you use sine on this last one here, opposite and hypotenuse, and then again you can switch these, since if we think about proportions, these would end up being multiplied anyway, so this moving here and this moving here is equivalent. So 12.2 divided by sine 41 is going to equal our x, and then we get approximately 18.60. So next we're going to talk about inverse trig ratios, and this helps us find angles, the inverse button. So it's got a little -1 as the exponent, that's the inverse, and that just reverses using our ratios here to figure out what angle it is. So we're going to try and find P. So I know that I have my adjacent and my hypotenuse. So I know A and H, and I need the theta, the angle P. So we're going to use the cosine inverse of A over H to get our theta. Okay, so cosine theta of our ratio 13 over 19 is going to equal angle P. So make sure that you are using the inverse this time. Sometimes you have to hit the second button and then type cosine, and then you type it straight in and hit enter, and we get 46.8. 46.8 degrees for angle P. So solving a right triangle means to determine the measures of all angles inside. So when we solve it, we're finding all the sides, we're finding all the angles. So you can solve either if you've got two side lengths or one side and acute angle, and then we can make our way through to figure out all the other pieces. So let's solve this one. Well, we've got two sides of a right triangle. How can we find the third side? Pythagorean theorem. Or you can use trig, a trig ratio, to help you, but you're going to need to find one of those angles first. So let's go ahead and find angle A, opposite, adjacent. So I'm going to use, for angle A, I'm going to use the tangent inverse of O4 over A. So that's going to give me 29.74, and this wants me to the nearest degree, so I'm going to round that up to 30. So if this angle's 30, well, I can figure out what this one is, because this is 90. So 90 minus, well, C is 90, but B is 90 minus 30, which would end up giving me 60 degrees. And then our AB, again, we can use Pythagorean theorem for, and there is that answer. Try that last one and check.